Hi, everyone. This week, we're going to talk about how to compare two means statistically. There are two methods for comparing means, and which you use depends on the type of data you have. Both of these statistics are called t-tests. If your data is from two totally unique groups, then you run an independent samples t-test. If I wanted to assess the job satisfaction of administrators versus faculty at our university, that would be an independent samples t-test because there is no overlap in who is faculty versus who is in administration. A dependent samples t-test happens when there is an innate connection between the groups that you want to compare. Dependent samples t-tests are also sometimes called a paired t-test. You see these very commonly used in biology. A biologist assessing toxicity at different parts of the same lake would want to run a dependent samples t-test because many of the characteristics of the toxicity test would be dependent on the same features of the lake across locations. Dependent samples t-tests are more powerful than independent samples t-tests because characteristics of participants or sample members are held constant, whereas there's much variation between the characteristics of sample members in the independent samples t-test. In business, the most common place to see a dependent samples t-test is when you're assessing data across time. If I want to assess job satisfaction for faculty at our university at the beginning and end of the semester, that's going to be a dependent samples t-test because the characteristics of those participants are the same. Let's look at how we run these analyses. I'm going to first run the analyses in SPSS, but I'm starting by showing you the data in Excel because it's not entirely intuitive how the data needs to be set up in SPSS if you want to run the assessment there. This is data that goes with the pizza delivery example in your chapter. It's data that assesses the amount of time needed to deliver a pizza from a local pizza delivery place and a chain. In this case, we're going to be using a dependent samples t-test because all characteristics of the process of delivering the pizza are identical, except for the fact that it's a local versus chain establishment. The first thing I'm going to do to move my data into SPSS is copy the numbers. Then I'm going to open SPSS, toggle over to the data view, and paste the data. Now we have the exact same three columns of data, except we have no headers. To insert our headers, we have to go back to the variable view. Our headers were time, local, and chain. If you haven't run into this already, be forewarned that SPSS does not let you name a variable anything that has spaces in it. So if I wanted to write chain restaurant here, I would either have to mesh the word together or connect it with an underscore because a space is not possible. I also want to go over here and I want to make sure that SPSS knows that this is continuous data. Now this looks very similar to how I had it set up in Excel. This column just shows that these are 10 different intervals of time. So our actual time data, those are located under local and chain. To compare the means, we're going to go to Analyze, Compare Means, Paired Samples t-test. Remember again, the dependent samples t-test is often also called a paired sample t-test. In this window, I need to identify the pairs of data. I'm going to drag local into variable 1 and chain into variable 2. I'll hit OK. And here's our output. Because our prediction was simply that the means are different, we're going to look at this two-sided p-value. We see that our p-value is 0.01, which means that we do have a difference and it's statistically significant. The difference in our means is 2.18 seconds. Notice that it's negative. Well, why is that? It's just because of the order in which I put in the data. If I had swapped that order, then this difference would have come out positive. But I put local in first. We see here that the mean for the local piece of business was 16.7 minutes versus the chain, which delivered an average of 18.88 minutes. Therefore, the local pizza business was statistically significantly faster on their delivery times than the chain. We can do this exact same analysis in Excel. We would go to our data analysis pack, scroll down to the t-test paired to sample for mean. For range 1, I'll select local. For range 2, I'll select chain. Our alpha level defaults to 0.05, which is what we want. And for output, I'll tell it to print our results in E1. So this is our local and this is our chain. Again, we see that the local is faster than the chain. Our two-tailed value is less than 0.05. So again, we find a statistically significant difference. Now we don't get the exact same numbers in the significance levels here that we did in SPSS, and that's because of rounding differences between the two softwares. But both still find that the local pizza establishment has a statistically significantly faster delivery time than the chain. Now let's look at an example in which we would need to run an independent samples t-test. This is a data set on customer satisfaction ratings with traditional versus prepaid cellular phones. Again, I'm going to show you how I would input this into SPSS because it's not that intuitive. Before I move into SPSS, I'm going to make a copy of column B and change it into numerical data. So here we have the type again, and this time I'm going to hit Control F, go to replace, and tell it that every time it says traditional, I want it to replace it with a 1. And every time it says prepaid, I want it to replace it with a 2. Now I can copy this numeric rating data and this numeric type data into SPSS. I'll go down into variable view to give it a name. And here I need to do something special. I need to assign values to the numbers in cell phone type. I need to make sure that SPSS knows that a 1 represents traditional and a 2 represents prepaid. Now I can hit OK. And now to analyze the data, I'll go to Analyze, Compare Means, Independent Samples t-test. I want to compare the differences in how customers rated the data across 2 groups, and I need to hit Define Groups so that SPSS knows that Group 1 and Group 2 are the 2 groups I want to compare. Now, SPSS preloaded that because those are the only 2 numbers that we had, but we still have to tell SPSS that it's correct. It's not making false assumptions. I'll hit Continue and OK. And here's our output. See how SPSS once again gives us labels here so we know exactly which group of data we're talking about, even though it's reading in itself as numbers? This is Levine's test for equality of variances. You talk about F-test towards the end of the chapter. A Levene's test uses the F statistic to identify whether or not the variance across your two groups is equal. If the variances are not equal, you have to modify your t-test calculation to account for that inequality. If Levene's test is not statistically significant, that means there's not a difference in the variances, and you can use the equal variances assumed rule. If the Levene's test value had been less than 0.05, then that would mean that there was a statistically significant difference between the variances, and therefore we would need to read the data on this equal variances not assumed row. But as is, equal variances are assumed. So we're going to look at our two-sided p-value, which is 0.78. What does this mean? It means that there was not a statistically significant difference in customer satisfaction based on whether they had a prepaid or traditional plan. So both customer groups seem to be equally satisfied with their plan. How do we do this in Excel? In Excel, we can use the data just as it was loaded for us. I can pull up my tool pack, scroll all the way down to two sample tests. Now, Excel is going to need you to go ahead and do the Levene's test on your own using the method shown in the textbook so that you know whether to choose the equal variances assumed or unassumed. That's another reason that I prefer to do this work in SPSS, because when you start the t-test, it does the Levene's test and then gives you your results. It's a one-step process rather than a two. We already know that equal variances are assumed. For variable 1 range, I'll choose the traditional data. And for variable 2 range, I'll choose the prepaid data. Okay. Once again, we're just testing for a difference. Our alpha level is correct at an assumed 0.05. I tell it that I want it to print the data starting in F1, hit OK. And there we go. Once again, we see slight differences in our output, starting with the means. And this is because due to the unequal sample size, Excel is calculating weighted means to try to accommodate for some of the variance in the data. But again, we see a statistically significant p-value telling us that there is no difference in the satisfaction rating across customers. Again, you have the autonomy to use either software that you want. But I strongly encourage you that as you work on t-tests, that you use SPSS. Your output might be slightly different than what you get in the book, but you're going to be doing a lot less work to get that output, and you're still going to get the same overall meaning from the data, which is whether or not there is a statistically significant difference in the means. So here's your introduction to t-tests. Please let me know if you have any questions.